Hello everyone, welcome back to our GRE series. My name is Eli and I'm a GRE trainer here at the Kenya Airlift program. So today we'll be looking at mixture questions which are relatively common in the Quant section of the GRE. Specifically, we'll be looking at how we can use alligation approach to solve these questions. So welcome and let's begin. Before we start with specific examples and problems, let's look at the basic structure of alligation. Now, mixture questions come in different ways in the GRE, but a common question is where you are given two solutions, which are then mixed, and you are required to find their appropriate ratios in the final mixture. For example, you may be given that solution X comprises 35% alcohol, and solution Y comprises 15% alcohol. The two are then mixed to give solution D that has 20% alcohol. Now, let's see how we can use this diagram of alligation to place this and solve the question. So for X, we'll have the higher percentage. So always set it up that you have the higher percentage here to make work easy. The higher percentage of the initial solution for our case is 35. And then down here you have the lower percentage of the initial solution, which is 15. Then the desired is the final one. The final percentage of the mixture you have here in the middle, 20. Then on this other side, we'll have desired minus Y, which is 20 minus 15, giving us 5. Then down here we'll have X minus desired, which is 35 minus 20, which is 15. Then finally you can set up your ratios this way. Have X over Y as desired minus Y over X minus desired, or X over Y, in this case, will be having 5 over 15, which you can reduce by dividing by 5. So finally, we have X over Y as 1 over 3, or just in ratio terms, X to Y is 1 to 3. So let's see how we can use this approach to solve or tackle mixture problems. The first one we have here is that seed mixture X is 40% ryegrass and 60% bluegrass by weight. Seed mixture Y is 25% ryegrass and 75% fescue. If a mixture of X and Y contains 30% ryegrass, what percent of the weight of this mixture is X? So we'll be focusing on ryegrass here because that is what the question wants. Now, X has 40% ryegrass and Y has 25% ryegrass. So the greater percentage here is 40. The other is 25%. So we'll have it down here. Then the final or desired is 30. So we'll have it in the middle here. So setting up alligation, we'll have here 30 minus 25, giving us 5. Here we'll have 40 minus 30, giving us 10. So X over Y should give us this one, 5 over 10, which we can reduce as divide by 5 to get 1, divide by 5 to get 2. So we'll have X over Y as 1 over 2. And we can write this as X to Y is 1 to 2. Now, what does the question ask? What percentage of the weight of this mixture is X? So we want X. X here, for this ratio, for each part of X, we have two parts Y, or the parts of X in this mixture, and the final one, is 1/3, which in percentage terms, just multiply by 100 to get the percentage, we'll have 33.33%, which is just answer choice B. Let's look at another example. Now, this one reads, how many liters of pure alcohol must be added to a 100-liter solution that is 20% alcohol in order to produce a solution that is 25% alcohol? So here we have pure alcohol. If it is pure alcohol, that means 100% of it is alcohol. So that is our higher percentage, 100. Then the lower one is 20%. And the final solution is 25%. So we set this up. We'll have here 100 minus 25, giving us 75. Then 25 minus 20, giving us 5. So let's have the pure, ratio of the pure to the dilute as 5/75. Reducing this by 5, 1 by 5, 15. So we have pure to the dilute one as 1/15. Or we can have this as ratios, that is the pure to the dilute one as 1/15. So for every 1 part of the pure alcohol liquid, we'll have 15 parts of the diluted one. And the diluted one, remember, is 100 liters. So we want to find the liters of the pure one that we need. So this one is like saying P over D, which is 1/15, is the same as some liters of P over 100 liters. So just working this out, we'll have P as 100 divided by 15, which we can reduce further. Divide this by 5 to get 20. Divide this by 5 to get 3. So the liters of the pure alcohol that must be added is 20/3, which is answer choice C. So as you can see, you can use this approach with different questions involving solutions or mixtures.
You are watching Success with Bob Mwiti Show, presented to you by the Kenya Airlift Program. The Kenya Airlift Program is an award-winning education financing scheme that helps bright Kenyan students to pursue graduate studies in North America, regardless of their financial background. You can find our programs by going to www.kenyaairliftprogram.com. The Kenya Airlift Program, empowering dreams.
Let's look at another example. This one here, we have mixture A is 15% alcohol and mixture B is 50% alcohol. If the two are poured together to create a 4-gallon mixture that contains 30% alcohol, approximately how many gallons of mixture A are in the mixture? So in this case, the higher percentage is 50, so we'll have 50 here. The lower percentage is 15. The final one is 30. So setting this up, we'll have 30 minus 15, which is 15, of course. Then here we'll have 50 minus 30, which is 20, of course. So we have mixture B over mixture A as 15/20. 15 divided by 5 is 3. 20 divided by 5 is 4. So we can say that B over A is 3/4, or B to A is 3 to 4. So what does the question require? We want the gallons of mixture A in this mixture. Remember, the total is 4. So for A, we'll have 4 over 7, that is 3 plus 4. Then multiply by the total, which is 4, giving us 16 over 7, which is about 2.28 gallons. Yes, basically just that and you are done. Another one. A chemist needs to mix a 10% acid solution with 35% acid solution to end up with 100 milliliters of a 25% acid solution. How much of each solution is needed? So here we have 10 and 35. The higher percentage, of course, is 35. The lower one is 10, and the desired is 25. Set this up. Get here 25 minus 10 is 15. And here we'll have 35 minus 25, which is 10. So the 35% solution, let's call this acid 35 over acid 10 should give us 15 over 10. You can reduce further by dividing by 5. 3 divided by 5, 2. 3 over 2. So we have acid 35 over acid 10 as 3 over 2, or the ratio of acid 35 to acid 10 is 3 to 2. But what does the question require? We have that the total volume of the solution is 100 milliliters. We want the volume of each. So for A, which is 3 parts, we'll have 3 over 5, that is 3 plus 2, times 100 ml, giving us 600. So we have 600 ml of that one. Then for acid 10, we'll have 100 minus 600, which is 400. Or you can tackle it the same way and have 2 over 5 times 1,000, giving us 400 ml. Just as simple as that. So let's look at our final example. Dr. Tick needs to make a solution that is 60% alcohol. If she has 4 liters of a solution that is 25% alcohol, how many of 80% solution will she need to add? So here, the doctor wants to mix one that is 80% with another that is 25% to get a final solution that is 60. She wants to make 60% solution. So here we'll have 60 minus 25, that is 35. Then here we'll have 80 minus 60, that is 20. So the 80%, let's call it mixture 80 over the 25% should be 35 over 20, reducing, divide by 5, 7, divide by 5, 4. So we have M80 over M25 as 7 over 4. Or we can say M80 to M25 is 7 to 4. Now remember, she has 4 liters of this M25. So this one is basically 4. And we want the liters for 80. So we have, basically setting this up, we have M80 over M25, and we know that the 25 is 4. And we want to calculate for M80. And this one gives us 7 over 4. So basically, you can see from this that we'll have 7 of M80, or you can just multiply it to get M80 as 7 liters, and you are done. So that is our final example. I hope you can now use alligation to solve mixture problems. Thank you for watching. I hope you've learned something, and welcome back next time. Bye.